Hi there. In this video, you're going to learn about how to solve inequalities. Your objectives for today are to solve inequalities by using addition and subtraction properties of inequality, and to solve inequalities by multiplying or dividing by a positive or negative number. Addition and subtraction properties. When you add or subtract the same number from each side of an inequality, the inequality remains true. So for example, if we have 5 is less than 9, if you were to add 4 on both sides, you would get 9 is less than 13. The inequality stays true. Same thing here. If you have 11 is greater than 6, and then you're choosing to subtract 3 on both sides, you're going to still have a true inequality. 8 is greater than 3. Now here we want to solve for x. So solve x plus 5 is greater than 12. Everything that you do for equations, you do for inequalities. The only difference is instead of an equal sign here, you're going to pretend like instead of an equal sign here, you have a greater than sign. So just solve everything the way that you normally would, and then you would get your answer. So x plus 5 is greater than 12. How do you get x by itself? You would subtract 5 on both sides. And if you subtract 5 on both sides, these 5s cancel out, and you're left with 12 minus 5, which is 7. Bring down the inequality symbol, and you have x. So x is greater than 7. So in order to check your answer now, you would plug in a number that's greater than 7 for x. So let's say 8 is your number. Let's say 9, 10, 20, 100. Any of those numbers can be plugged in for x, and your inequality should still remain true. So in this case, I'm just going to plug in 10 for x. Is 10 plus 5 greater than 12? Well, yeah, it is. 15 is greater than 12. Okay, and graphing an inequality. When graphing inequalities, it is often easier to visualize the solution when the variable is on the left side of the inequality symbol. So like this. Notice that when you graph 6 is greater than x and x is less than 6, you get the same graph, which is this, an open circle on the 6 and then an arrow pointed to the left. Because x here, if 6 is greater than x, then x has to be 5, 4, 3, 2, 1, etc. Now here, if x is less than 6, again, 5, 4, 3, 2, 1, etc. So it would be an open circle on the 6 and an arrow facing the left. Here is our next example. 3 is less than or equal to b minus 1 1/3. Graph the solution in a number line. So here we have b minus 1 1/3. How do you get b alone? You would add both sides 1 1/3. So that's what I do here. I add 1 1/3 on both sides, and these cancel out. And I'm left with 4 1/3 is less than or equal to b. Or you can think of it as b is greater than or equal to 4 1/3. These two are exactly the same. All I did was put the variable in the front here. Here it's in the back. So since the inequality symbol is a greater than or equal to, draw a closed dot on the 4 1/3 with an arrow to the right of it. Okay, and then to check your work, you can plug in any number that is greater than 4 1/3 because b is greater than 4 1/3. Or you can use 4 1/3 if you want. So I'm going to use 5 1/3. So 5 1/3 minus 1 1/3 gets you 4. And this is the original inequality, right? 3 is less than or equal to 4, which is true. Multiplying and dividing positives. So far we're still the same thing. So far, all the rules of solving inequalities is the same thing as solving equations. When you multiply or divide each side of an inequality by the same positive number, the inequality remains true. So here are two examples right here. Negative 6 is less than 10. Let's say I multiply both sides of those by positive 2. I'm going to get negative 12 is less than 20, which is still true. Same thing here. If I divide both sides by 4, I'm going to get the inequality 5 is greater than 4, which is still true. All right, and here I have 7c plus 6 is less than or equal to 45. Let's solve this inequality. It's a two-step inequality. So same thing like you would normally solve a two-step equation. Undo the addition or subtraction first. So I have 7c plus 6, I would need to subtract 6 on both sides. So I have minus 6, minus 6. On the left, I'm left with 7c is less than or equal to 45 minus 6 is 39. Once I get to this step, 7c is less than or equal to 39, I would divide both sides by 7, and I would get my c to be less than or equal to 5 4/7, or the decimal 5.571,428 repeating. Okay, so either way, you still get the same answer. Now here's the tricky part, is when you multiply and divide by negatives. If you are multiplying or dividing both sides by the same negative number, you need to reverse the inequality symbol. I would suggest you pause the video and write this down, because this is very important. This is your major difference between inequalities and equations. So if we look at the examples here, we have negative 4 is less than 5. If I multiply both sides by negative 3, negative 4 times negative 3 is 12. 12 is greater than negative 15. So this, I change the inequality symbol from a less than to a greater than, because I multiplied both sides by negative 3. So let's look at here. I'm dividing both sides by negative 3. So this inequality symbol is going to be flipped from, this inequality symbol is going to be flipped from a greater than to a less than. All right, here we have negative 5x is less than 45. How do we solve for x? How do we get x by itself? Well, if negative 5 times x is less than 45, you would divide both sides by negative 5, right? Because we need to get x by itself, not negative 5x. Sorry about that. You would just simply multiply by negative 5 on both sides. Negative 5 over negative 5, those two cancel out, and you're just left with x on the left. This inequality symbol needs to flip because you're dividing both sides by negative 5, and 45 divided by negative 5 is positive 9. And then you can check your work. So just plug in any number that's greater than 9 for x. I'm going to plug in 10. Negative 5 times 10 is less than 45. And let's check. Negative 50 is less than 45. My check works out. Here I have b over negative 8 is, b divided by negative 8 minus 2 is greater than or equal to negative 8. So if I have this fraction minus 2 greater than or equal to negative 8, first thing I'm going to do is undo the addition or subtraction. So here I have a minus 2. I'm going to add 2 on both sides. This negative 2 plus 2 is going to cancel out, right? On this side, I'm left with b divided by negative 8 is greater than or equal to, well, negative 8 plus 2 is negative 6. Now, how do I get b by itself here? B divided by negative 8. I need to get b by itself, so the opposite of dividing by negative 8 is to multiply by negative 8. So that's what I'm going to do, is multiply both sides by negative 8. Negative 8 divided by negative 8 is 1, so those two cancel out, and I'm left with b on the left. This inequality symbol is going to flip because I just multiplied both sides by a negative number, so it'll be b is less than or equal to negative 6 times negative 8 is 48. And then you can just check. So plug in any number that's less than or equal to 48. Any number. You can plug in 0, you can plug in 1, 2, 5, 40, whatever you want. I'm going to plug in 16, just because I can divide by negative 8 easily. So I'm doing 16 divided by negative 8 minus 2 is greater than, I'm just replugging it in to the original problem. So 16 divided by negative 8 minus 2 is greater than or equal to negative 8. And then if I solve both sides of that, you get, if you solve both sides of that, 16 divided by negative 8 is, 16 divided by negative 8 is just positive 2. Positive 2 minus 2 is 0. 0 ends up being greater than negative 8. So just your concluding thoughts. Solve inequalities the same way you would solve equations using inverse operations. And the big difference is when you multiply or divide both sides by a negative number, you need to reverse the inequality symbol.